welcome, welcome. Doing more leak code problems. Looks like I am at number 24. Is that right? Yeah, today is the 24th. And let's see if this one is easy or hard or whatever. The only way I know how to do that is to search for it and find it through this interface. Alright, so it's a medium. So I think the last several days have been mediums. Ooh. Hey. I'm not so scared of them anymore now that I've done a ton of them. So yeah, let's get cracking. So today we're going to design and implement a data structure for least recently used cache. Pop that open. It should support the following operations: get and put. Get will get the value. Always be positive of the key if it exists in the cache, otherwise it will return -1. Okay. Put will set or insert the value if the key is not already present. When the cache has reached its capacity, it should invalidate the least recently used item before inserting a new item. The cache is initialized with the positive capacity. Okay, so that sounds good. This is a common way of caching data. This is like it's kind of, I think of as being the standard de facto way to do caching. Is basically more often than not, data that is accessed more recently is more likely to be accessed again in kind of normal caching scenario. So it's, you know, depending on use case, it may not always be the best, but yeah, should be pretty good. So I don't think I've ever programmed one of these. I've used them before, but it doesn't really sound that hard. So they do ask us to do both operations in 0 at one time, which makes me immediately think of a hash table, which should be fine. But the eviction is a bit of a problem because we have to know to evict the right one. So immediately I'm kind of thinking about like two data structures here. One for the fast lookup and another one to tell us which one to delete when it's time to do that. As for the lookups, mentioned that hash table is going to be great. It's going to get us that O1 lookup time. As for which one should go, basically whenever we get an item, we're going to need to basically mark that one as the last one that should be deleted. So somehow it needs to kind of sort to the top. So we'll want to use a data structure that's appropriate for that. And then we'll be done. So that's really kind of the hard part. So yeah, let's do this. I don't think I've ever done a problem like this. It's kind of where we're responsible for filling in multiple functions. And yeah, I mean, that looks fine. Okay. So we get an LRU cache with capacity. That allows us to kind of initialize our data structures. And then we've got our functions for put and get. All right, we got some samples. Okay. So yeah, I mean, this is not too bad. Let's see here. So when we initialize this, we'll call it our internal cache. There it goes. And when we get an item, we will return this dot cache is equal to null, then -1. Otherwise, we'll return this dot cache. And for putting the item, sorry, we do it this way. LRU.cache at key is equal to null. Then it's -1. Otherwise, it's this. All right. Down here. There's probably a slicker way. I probably could do this. Whatever. It's fine. So there's a little bit more work we have to do, but I kind of just want to test this. Less stuff to debug. So I fully expect to get the wrong answer here because I'm not actually invalidating anything. But this is the kind of stuff I actually wanted to flesh out. cannot set property 1 of undefined. Okay, so the cache is not getting created. Which is, oh, this is function capacity, okay. So yeah. Your LRU cache, I need to return something here. Yeah, I need to return something here. I don't know. Let's try this. See what kind of error we get. I don't typically deal with like JavaScript kind of, okay, cool, classes and stuff. So I don't really think too much about how to kind of put this stuff together. I tend to not do very OO type stuff in JavaScript. I tend to do stuff like this in JavaScript, coding challenges. Okay, so this was enough of a right answer to let me know that I'm on the right track as far as initially using my objects and stuff. And so I've definitely got a problem because I'm not obeying this kind of capacity rule here. It's the second half of the problem. I just want to make sure I was getting stuff stored right. So that's good. So now we got to think of a data structure that's going to be good. It's going to need to write this down. I need to be able to update it in O of 1. Updates. And I need O of 1 for removal. And what do I mean by update is basically whenever I see a new item, I need to be able to kind of bump it up to the list to make sure that it doesn't get deleted. So I'm just going to kind of list a couple options that I can think of off the bat. We're going to say no trees because trees, pretty much all of them have some sort of, oh, I think I just figured out the answer. Logarithmic time for traveling through the options of the tree. Arrays are also a bad choice because moving items out of array means shifting the whole thing. I don't think graph makes any sort of sense. And I mean, we've eliminated some pretty big things here. So now what I'm thinking about is the linked list. So a linked list does allow for cheap updates, especially moving to the front. And removing from a linked list can also be really quick. So I think that's going to work out really well. Now we will have to do some kind of weird stuff, I think, in order to kind of hop to the middle of the list, because the thing a linked list is not good at is search. So we'll call it traversal because you have to go through each individual item, but I think that we'll be able to work around that pretty easily here. So what we'll do is in here, so we will create, I'll just call this list. Maybe we'll call it whatever, we'll call it list, it's fine. And what'll it be? It's a linked list. So next is null. And for the head, we'll just say my value is null as well. So yeah, that is good. All right. So when it comes time to put an item onto our list, we can say if our list dot next equals null, then our list dot next equals one of these new objects. All right. So that looks pretty good. And then we'll actually need to store my value in here. And I'll set the value to the key. All right, and we'll see what that's for in a minute. If this item is already in the list, okay, I need to rearrange a few things here. Give me one sec. Our LRU cache is still a map, but now our LRU cache needs to contain a little bit more information. So when we create this here, what I'm going to do is keep a key to value, which is our actual value that we're storing here. But also now, I'm going to keep a pointer to my position. What are we going to call this? My I'll call my node. And my node will equal the spot in this list that I'm creating. So I haven't figured this out yet. So we'll do this afterwards. Yeah, we'll do this afterwards. Hopefully this is making sense. I'm kind of scattered here. All right, so if our LRU cache dot list is null, meaning we have no items in our cache yet, then let's go ahead and make our next item equal to the first, I'll say key, the first key, and it's the next item in this linked list is null. And I'm going to go ahead and make it a doubly linked list because I think that will make things just a little bit easier for us. So up here, I'm going to change the name away from value to key just because I'm getting confused already. All right, that looks good. So if the list is not null, then what do we do? Well, if we've seen this item before, meaning it already exists in our cache, then we know it should also exist in our linked list. So we can take our linked list and search for it, but I don't want to do that. Linked list, because that's going to be slow. So what I'm going to do instead is rely on that value already being in my cache here. So I'll say get the item out of my cache and get its node. And this item is going to go where? Yeah, it's a little tricky. I want this item to basically go at the end of my list. Okay. Yeah, this is, I see, this is trickier than it sounds at first. All right, so I found the item in the linked list. It's right here. Now I need to make sure it's the last one to get cleaned up. Basically, the last one to get removed from our cache. And I can do that by adjusting its position in the line. So what I'm going to do is take this LRU cache dot list, and I'm going to insert it at the front. Basically by doing this. Except that instead of its next being null, I'm going to take in whatever it used to be. So I'm going to bump that item to second in the list. That's all good. Okay. So just to go back over this, make sure I'm doing this right. If there are no items in our linked list, then we will stick it at the front of our linked list. Otherwise, if it does already exist in the cache, then we are going to move it to the front of the list. So const existing node, and we'll get this item. So this is the item that we're moving from somewhere else in the list. And what we'll do is we'll say that its previous equals no, it's not quite right. I need to get its previous dot next and set it to my next. So basically skipping over this item. I've effectively sliced this item out of the list at this point. So I'll call this actually remove the item, the node from the linked list. by doing that. So go back a step and then set its next so it hops over me. And now I need to set its key is fine. Its next is going to be my node. And what does last mean here? I shouldn't do last, I should do previous. Last is confusing. I don't like that word. Hey, happy Friday, by the way. How y'all doing out there? What's the last one to get removed? Okay. So, for its previous is an interesting question. I might want to make this a circular linked list. Which is a bit odd, but I think I kind of like it. I don't know. We'll come back to that. I'll put a little to do circular. Because I think when it comes time to remove the item, we're going to know which one, we're going to want to know which one is last, which is fine. So just to kind of work through this one more time. If we have no items in our list, put this in the first position. If the item already exists in our cache, then all we need to do is bump it to the front of the list and we're done. So we get our existing node, we slice it out of the linked list, and then we put it at the front of the list, setting its the front of the list next equal to me, my node. Okay. Its previous equal to null, and its key equal to the key that I'm getting here for the cache key. Okay, this effectively puts it at the beginning of the list. This doesn't sit right with me though. I think I should actually be setting its next equal to existing node, but only after I set existing nodes next. Yeah, there we go. Equals the current first item. Yeah, this is better. Talking about linked lists is really confusing. Hopefully it's not losing anybody. And its previous is going to be set to null. So not the slickest thing I've ever done here, but it's alright. So I'm just going to type this out. Find the existing item in the linked list. Okay. Then we're going to slice it out of the list. Which effectively, say it bypasses. I think that's good enough. Then we'll make sure it's the last one to get removed by placing it in front of the line. To remove its previous left sibling, because now it's first. And may want to reconsider this one. To reconsider. Because this is where we may want to set it to the last item in the list to kind of save us some time. But we'll get there. That's optimization. Okay, and then finally, place it. So I should do this. This whole operation is all about putting it into the front of the line. So I'll just leave that like this. All right. Okay, so that's if the item does exist in the cache. If it doesn't already exist in the cache, then it's actually not that different. Basically, we just take the current item and we still need to put it at the front of the list. So we got the key. Its next will equal whatever is currently in the front here. And the previous will equal null, which this is also a maybe. So both of those I'll kind of leave ticklers for, so I think we're going to come back to those. All right, so I think that's it for put. So just to kind of say it again, what does this do? Add the item to a hash table. Add the item to or say move/add the item to the front of a linked list. There's one thing I need to do here that I haven't done yet. If the linked list is too long, remove the last item in the list. Okay. So where should we do that? I think we should do it right here at the top. If our cache if the items in our cache, object.keys, is greater than or equal to our capacity, and I think that's good, greater than or equal to. What's up, Abdul? How's it going? This is definitely a different problem today. If the item is too long, then we'll go ahead and remove the last one. And this is where I don't want to iterate through my linked list because that's going to be too slow and it's potentially n. And the if you remember, we're going for O of 1 in the description of the problem. So what that means for me, oh, by the way, hey, let me know if that music is too loud. I was just trying something different. It's all royalty-free stream music. Let's see here. If it's greater than or equal to the capacity, then I want to remove the last item. So I'll say last node equals LRU cache.list.previous, I guess. I don't know, that's kind of messy. All right. And then to remove it from the linked list, we got a doubly linked list, so it's easiest. It's easy. We go get its previous, and we set its next to null, and then it's gone. We've removed the reference. Next, we also need to remove it from the cache. ucache.cache. We need to delete. And I think that's it, but we do need to make sure that we save this appropriately. I don't know, I think I might just set this to last. So this will be kind of a special node. It's gonna, cool, glad to hear it. About the music, thank you. All right, so then the last trick is that whenever we insert, we need to set this last item, or whenever we move an item. I definitely don't like how much code I'm writing here. Makes me feel like I'm doing something wrong. All right, so think here for a minute. If there's no items in the list, they said we'd always have a positive capacity, so we never have to worry about it. But we do have to set our last value because it just so happens that last equals the next. Now, whenever we move an item, I hate that. Whenever you control F, it pops that open. Basically, whenever we move this node here, we need to make sure that if it's the last node, that we update the last node. So, the way you tell if it's the last node is basically if it doesn't have a next. So, if existing node dot next equals null, it's the last node. So we need to change the last node to be whatever is previous to it. Existing node dot previous. Okay. Oops, dot last. Okay. And if it doesn't exist in the list, then I think we're good. I think this might be it. Let's see here. And then I don't think I have to do anything here or here. So I'm just going to walk through this one more time. So what I'm doing, I don't know if you did this one already, Abdul, but basically what I'm doing, the general approach I'm going for is that I am storing a linked list to keep track of the items in the order that they've come in. Hey, what's up, Nico? Long time no see. Hi, well, hi everybody. What's up, Nico's Freds? Yeah, so I'm doing a linked list for keeping track of the items, and then I'm keeping a standard hash table for actually the values here. So when I initialize, I start a hash table. I start up a linked list that's all null. Oh no, no audio. Okay, well, this is for you. It's a little dance for you. Let's see. I'll put it in the chat here. All right. So that's our linked list. And one thing that's kind of special about the first node in our linked list is I'm keeping a pointer to the last item in the list as we go along. And that's the trick for making sure that we have a linked list that we can keep track of both the head and items at the end in constant time. And also, whenever we cache something in the cache, I'm also stashing it a link to its node, so I don't have to look it up. And so all around, I'm hoping that's going to buy me that constant time. Yes, I haven't done that part. So good call. I do have to, yeah, I do need to bump up get whenever I get it. So yeah, good call. Yeah, and it's kind of weird to think that, like, I probably did all this work in get and put rather, but I should have done it in hash. Not in hash get. Jeez. It's Friday. Happy Friday. Yeah, so all this work I did here, I should probably do it only in the get. Well, that's fine. Let's see, what did I do with value? Yeah, I think actually probably all of this stuff should have only happened. No, that's not true. Okay, sorry. Yeah, then we're good. All right, glad to hear it. All right, so we've got a linked list, we've got a hash. So on the put, what I'm going to do is basically add the item to the hash table with a pointer to its node in the linked list. And then we're going to move or add the item to the front of a linked list when we put, and this should probably be shared with get. If the linked list is too long, then remove the last item. And yeah, because I'm dealing with the possibility of like duplicate puts, I should probably not do this here. I should do it at the very end. So I think I should do it in this order. Oh, we'll see. All right. Should I just bring this out to, should I bring this out to a separate function? Let me think. What do I do with value? List next key. I never put the value in here. That's fine. Here's where I use the value. So I should never use the value in any of this stuff. Okay, cool. So I'm going to move all of this out to its own function called bump. I'm going to bump key. Type.bump. It'll take the key that it's bumping. So all this stuff up here needs to change a little bit. So now this part is moved out. This part can stay. So bump is a function, and what bump does is basically oh, it's kind of weird. I don't like that bump actually will change things. Bump shouldn't just add to the list if it's null. That's kind of weird. So that I don't need to do that stuff on a get, but I suppose it doesn't hurt. So let's just try it. This might end up being a little weird, but basically the deal is on get, I also need to bump this key up. Just to kind of make this. Oh, but I only need to bump if the item actually does exist. So yeah, this functionality doesn't belong here. So this is specific to get. Or, geez, I keep saying the wrong. I always say the wrong thing. Put. This stuff is specific to put. So if the item doesn't already exist, then I'm gonna put it in here with the key. I don't know. We'll see. So I make sure the item is in the list. Is that true? I might put it at the beginning, and then I run bump, then we cache it. Should I cache it ahead of time? Yeah, I think that makes more sense to me. And then down here, whenever we get the item, we could either do this before or after the fetch. I might as well get it first. So we'll bump the item so it's first in line, so it's the last one to get removed from the cache, and then we just return. That's it. So in theory, this should all work. But based on the kind of errors I'm seeing in my own code, I'm sure it's not going to work the first time. Let's run through this one more time, thinking about the perspective of a put or a get. If we're putting it, we say if the cache has the item, then find the item in the linked list, take it out, put it in front. If it doesn't exist, well, let's go ahead and put it in there. Okay, so then down here at the get, I only need to bump if we actually have a value. So, rewrite this a little bit. If the item is null, then we just return -1. Done. Else, we will bump the key, and then we don't have to do this check anymore. Just do that. Okay. Drum roll. Awesome. 39. Oh, I never set the node. Why wouldn't I set the node here? the node needs to be my item in the list, which I don't currently get. I don't know what the item is in the list is yet. Is that something I can return? Yeah, this is kind of important. Our cache needs to have a pointer to our item. Huh. What is this stuff doing? This stuff is weird. Yeah, something is not right here. I'm saying if the list is empty, then go ahead and put that item in there. Okay, and then at that point I know that our node is always that. So I think that means I can just put this here. But I'm gonna double check that. So when we bump, what happens if the item isn't in there? If our cache has the item, what should happen if you, see if it even tells us what should happen if you try to put the value if it's not already present. Okay, so I don't think we need to bump. Let me read that one more time. Get the value or the key if it exists. Otherwise, set or insert the value if it's not already present. When it reaches its capacity, it should invalidate the least recently used item. Used item, not put item. So I should not bump at all here. So I'm always going to put it into the front of the list. And then I can always get the node right there. Which means I don't care if this is null or not. It always needs to go in the front. LRU.cache.list.next equals my node. Nope, that's not true. Jeez. Alright, sorry for the confusion. If the item already exists, I just buck out. If this is not equal to null, then we just return. That's it. And I don't have to think about anything else. Otherwise, what is all this stuff? Otherwise, I don't care if the list is null or not. I'm putting it in front no matter what. You still bump if the key already exists. Yeah, because otherwise it's kind of weird. It's like, where do you put it in? Is it considered used? Alright, I like that. So, when we put, if the item already exists, then we'll bump. That counts as a use, I guess. We'll bump the key, and then we'll get out of there. Otherwise, the item doesn't exist. We'll put it at the front. So our LRU.list.next equals our new node. And our LRU cache list last. This is the one that only needs, this is the thing that only needs to happen. Oh my gosh. If LRU cache dot list dot next equals null, and this needs to move up a line. Why am I having such a hard time with this? This is like kind of standard dev type stuff, but for some reason it just keeps tripping me up. If my next item in the list is null, meaning this is the first item in our list, then it also needs to be our last. So I need the same node. On new node. Up the value inside the first if block. So if we have the item in our cache, then do we need to update the value? Yes, we need to bump it to the front. And then we can get out of there. I think. This is the one that the directions are wishy-washy. Does this count as use? I guess I don't have to be mean to the directions. I probably misread it. Does this count as a use? Alright, then we create a new node with our key. Its next value equals whatever the next item was already, which could be null. Its previous is going to be null. Okay. But because this is a doubly linked list, I also need to update its next item. I should have really separated out the list object and just remove that logic. I mean, set the value property, not just bump. Good call. Yeah, I'm assuming that has the same value for some reason. That's, yeah. Good call. Good call. Dot cache at key equals value. Duh. Good call. That looks a little nicer to me. So if we already know about the item, just update the value and then bump it to the front of the list. Else, let's create a new node and let's set its next equal to whatever's currently at the front of the line. It has no previous. Now, the item that was formerly at the front of the line, this item, so we'll do it like this. If former first is not equal to null, then former first previous equals new node. Okay. And if the former first was null, we do it like this. I don't like knots. Then we also need to save the last. So if we didn't have this is the first item in the list, then it also needs to be our last. Otherwise, we need to set its previous equal to us. Okay. And then we need to set the front of the list to point to our new node. Okay. Then here the key equals the value. Okay. And its node is also equal to new node. Okay. Now the only other thing we have to worry about then is if we exceeded the boundary of our capacity, and the capacity here should be LRU Cache.capacity. If that's the case, then we find the last item in the list. We set its previous parent equal to null, because now it's the last item, which also means I need to set the last item equal to this. And that could be null, and that'd be fine. Okay. And then we delete the last item from the cache. Done. And then when it comes to getting, if the item does not exist in the cache, it's -1 according to the docs. Otherwise, we bump it and then return the value. This should all be constant time. And we said this does count as a use. So let's see how many syntax errors I have. Line 32. Oh, I just changed the line. Yes, you're right. I should not just be setting the value. Good call. So here, I made this a complex object, which has a value and what? And what indeed? What do I call it? Node? Oh yeah, I could just do this way. Value equals value. That seems a little nicer. Okay. And I don't have to worry about changing its node. All right, let the syntax errors begin. That's set value of undefined. LRU cache. In get, I have to return the value. Yes. Good call. Good call. So what didn't like about this? I said if this object is not equal to null, LRU cache dot key dot value equals value. I'm verified that it's an object, so it makes me think I put something bad in here. No surprise. This should be the only place that ever adds though. Is that true? I delete the whole node there, that's fine. Why would this be undefined? I literally just checked it, didn't I? Say if LRU.cache at key is not equal to null. It set its key to the value. Set it at the key to the value. So I'm just going to copy paste this in case I typoed. Whoa. Value equals value. And down here is where I set it. LRU cache dot cache at key equals value. I didn't change anything, so I don't expect any different answers. Cannot set property value of undefined. You know what? Last time we had a weird JavaScript error. We refreshed the whole page. And it worked. I don't think that's the case here. Alright, you know what time it is? It's code time. Call this LRU. So now I have to figure out how to actually call this. So I'll create LRU cache of 2. Equals a new cache of 2. And I'll say cache.put 1. What happens? Okay, let's debug this thing. So it's the very first put that's erroring out. Put. So LRU cache dot cache is an object dot key. Oh, it's not equal equal null. Yeah, Gavin, that's the plan. Be doing a longer stream. And honestly I forget if I if I'm pair programming with Super Good Dave or with Outlaw. So I need to figure that out. Yeah, it does sound a little naughty. All right, so this is a stupid JavaScript thing. So I'm just gonna see what it should be. So if we have a map, and I want to check if an item exists or not, this key does not exist. However, that's not equal to null. It's equal to undefined. So, yeah. JavaScript, ladies and gentlemen. Alright, so now if we run this thing, then we get an answer. I don't know what kind of answer. Oh, I ran an older problem. Jeez. Okay, it ran without error. I don't know what it put out. Cache.put doesn't actually return anything, so not very exciting. But I should be able to say cache.get now, and this should have had a value too. I'll do a better key here. Sure. And I'll say get ABC. Now I expect to see 2. Oof. Nope. I didn't like my LRU cache.bump. That's because I shouldn't have called it LRU cache.bump. What should I call this? I think it should just be this dot bump. Let's double check this. I kind of shrank my browser up so hopefully it'll be legible, but now I can't read it because it's too big. LRU cache.bump is not a function. Okay, well, I'll tell you how. We can fix it like that. All right, let's try that. Now it doesn't like this. Existing node.previous.next equals existing node.next. I think we should always have a previous. So wherever I'm setting previous equal null, it should not be. It should just be the head, which is dot list. All right. Okay. Am I setting somewhere else previous equal to null? Yep, right there. All right, what's the next error? I typed way too much. I should have checked more often. Again, same error. Is that really the case? Oh, yep. I guess I create a lot of new nodes. So, there we go. Got the right answer. Yay. So now our capacity is 2. So if I add another key called DEF and give it a value, I'll change these values. So I should expect to see a 1 here. All right, and we're gonna put, I won't get anything. So I just do that, a little bit cleaner. Now we're gonna push DEF. Even this I'll shorten down to A and B. And we should see a 2 when we get B. That would make me happy. Okay. Let's put a third item. Now I expect to see a 3. Very exciting. But now when I do a 1, or rather an A, I expect to get a -1 because the item should have gotten bumped. Okay, that's not good. B should still be in there as 2. Let's make sure that's the case. Okay. So basically my thing that checked the length didn't fire. Alright. So it's when I add this item right here. So let's debug this thing. Oops. Alright. We're so close here. So we go into bump. And then we return the value. Yeah, we already made sure that. Oh, but okay. No, that's okay. That's okay. That's all right. If the item exists in the cache, yep. Then we go get it. Okay. Key of C. Wait, what did I set my debugger on? What the heck? The wrong line. I meant to put it here. All right, I'm too late. Sorry. Let's try this again. Okay, now we're putting the C on. All right, F11. All right, the item does exist. The item does not exist. So why didn't this happen? The LRU cache A and B at C should have equaled undefined. What the heck? Let me make sure I ran that correctly. We're putting a C in, stepping in. If my LRU at my cache, which only has A and B in it, at key of C is equal to undefined, it skipped it. Shouldn't this be not equals undefined? Oh, it is. Oh, geez, the ligature threw me off. It is not equals. Okay. That was exactly what should have happened. Whenever I'm doubting the compiler, I just need to remember. Okay, we go and we are getting the former first item, which is B. That's good. A should be last. So if we look at list.last, we should see that it points to A and it does not. So that's the problem. We didn't update last. So this was a problem even before we got here. So I'm just going to set a debug point on put. Start this thing up again. Now we're pushing it A. Get out of my face. All right. The first item is currently null. It's okay. We create a new node. It has no next. Its previous is equal to the front of the list. Our key should be A. Check. If that's null, it is. Then we set our list.last equal to the node we just created. So this looks like it's happening. Yep. So we have a last at this point. You can see it right there. So our first put was good. We're not over capacity. So at this point we're good. All right, let's skip over. Now we're putting the second item in the list. I'm just going to verify that the last item is set. We have last. No, it's incorrect. What? Did bump mess it up? So let's look at what happens at our get. It calls bump. what happens in bump? Just to verify. Yeah. All right. Let's start this over. Now I think the error is in bump. All right. So this is getting called from. Where's our stack trace? Call stack. This is getting called from our get. So all of this is good. This is all good stuff. All right, so we're getting our A. Say, does this item have it? It should. So yes, so let's go get the current item from our cache. There it is. Okay. Its node has a next of null because it's the only item in the list. That's good. Okay, its next is null. Oh, so look at this. What am I doing here? I'm saying, hey, if you are the last item in the list, then I'm setting the last item of the list equal to my previous. Why would I do that? What did I want to happen here? If this is the last item in the list, I should only do this if it's the only item, if it's not the only item in the list. Let's see. So if it's next is equal to null, that's the last item in the list, and existing node dot previous is not equal to LRU cache dot list. All right, so existing node previous is equal to an object, and that object is our last and next is this item. Yep, so good. All right, so let's try this again. So we come back into here, come down, come down. We did not hit this condition, so we did not rejigger the last item in the list. And really, none of this stuff should happen unless it's not the last item. But it shouldn't hurt either. Okay. Let's see what we get out of here. So we're turning the right value. Now this time when we go to put, we should be able to look at our LRU cache dot list and see that the last is correct and our next is correct. Okay. Swoop back around. Look at our next put. This time it's putting the B in. Oh no, sorry, this is putting the C in. Okay, but if we look at our LRU cache dot list, what do we got here? Okay, this time our next value is correct and our last value is correct. And our next is correctly pointed to our last. And is our last correct? Yeah, good. All good. I think this is it. So if we run it to completion, I don't see where the output went. Let me try running it down here. Still got the wrong value. Okay, I guess I went too fast. One of these days I'm going to learn that going slower is actually faster. Okay, so this is pushing our A, pushing our B, pushing our C. So what I want to see this time is Are we seeing our next appropriately? Yes. Now it's next of C. Okay. We set our cache. Did I ever set my new nodes next? Set next equal to former first, which is B. Okay. I mean, I like all that. So we update our cache. Okay, so if I look here, in our list, I'm seeing the next correct value of C. It points next to B. Yep. It points next to A, and I see the right value in A. So all of this looks good so far. I don't really care about the cache right now, but here is where the mess up is. I get the keys of our LRU.cache. There should be 3 of them. Yep. That is greater than 2. Yep. What? Object.keys.length. Oh my gosh. Alright, Nico. Sounds like a good time. I'm actually missing a virtual happy hour right now for work. I need to hurry up and bounce over there. They're going to catch me streaming. Alright. What's more fun than coding, though? Alright, so that was another stupid JavaScript thing. I'm just going to run this again. Oh my gosh. Got another error, great. Cannot eat properties of null. This happened on line 43. So right here, this is our first time running into here. Hey, have a good one. Have a good one, Nico. So if my cache.length is greater, then that's good. So what I do is I say, hey, LRU cache.last, okay, last nodes.previous. Need to make sure that I set that correctly. It's next equals null. So I'm happy with that. So it makes me think I've got it set incorrectly. Let's try this. And this should only hit on the C. All right. So our last node is A, which I expected. Its previous is B, also what I expected. Good. So I say last node dot previous, which is B. Its previous doesn't look right. But this is, I mean, that's good. So its key is B, check. So I'm saying its next should be equal to null. So I mean, that looks good to me. Wait a second here. Last node is A. Last node's previous is B. Okay. And its next is currently A. But I'm saying unset that. Now set this to null. Okay. So no error. That's interesting. Now we're saying, hey, set the last of this equal to, oh, I just set this to null. I just lost this value. So this needs to happen first. Last node dot previous dot next. Yeah. I did it too early. All right, let's try that again. Oh my gosh. Line 16. This is, one of these days I'm going to remember to test in smaller chunks. One of these days, not today. LRU.cache.key. Didn't I change this to undefined? I must have did it in one spot and not this one. All right, we got the answers we expect. Let's write a couple more tests. What if we test for a key we don't have? I guess we already kind of did that there, but a key we never had. Oops. -1 equals some longer key. Sure. Okay, what else could we test? Oh, we could test that adding a key again bumps it. All right. So in this case, I still have A, B, and C. I dropped A out. So if I put A back in with a value of 13, then I should get 13 back out. Make sure that's right. Yep, okay. Now if I put B back in 14, then I should get B back as 14 for B, and I should also get A equal to 13 because A should still exist. C should have gotten bumped out. So let's do that. All right, hopefully that all comes out. Yeah, all right, so I think this is good. I think that's it. So this is 70 lines. This is kind of a different problem. Like, I don't think this problem was particularly hard. It's just a lot of typing. There's a lot of stuff to get tripped up on. Kind of finicky. But I think this is a good solution. I'm sure we'll see people doing stuff in less lines. But overall, I think this will be a common strategy. Let's see here. Did we get the right answer? How on earth did we get the wrong answer here? No, no, no. -1 and 1. So they put two. I don't know how to read this. Okay, capacity 2, I see, okay. So, all right, we can do this. We'll just do these tests exactly. All right. So they push 2. And then they push the value of 1 with the key of 1. I test with strings, not with numbers. Shouldn't matter, but the cache push a 2 with a 2. And they do a get of 1. So let me delete these as I go. And then they push a 3 and a 3. They get a 2. Then we got some 4s, very exciting. Big numbers now. We get that 1, get the 3, we get the 4. All right, I think I translated that correctly. And I didn't output any of it. Oh my gosh. I'll just do it this way. Oh, let me change that a little bit. We'll do the multi-vertical line selector. I'm gonna have to, of course, go in and fix those. All right, so all the puts will have null. This should equal 1. We put 3, getting a 2. Should get a 2. Yep. Putting a 4 is null. Getting a 1 should now get a -1. Should have been pushed out. Getting a 3 should be fine. And getting a 4 I think is fine. Let's try that. Okay, null equals undefined. Undefined. I think that's probably fine. 1 equals -1. What the heck? So wrong right off the bat. Like, what happened there? Let's just Make sure I read that right. 1 equals -1. Okay. Well, I'm glad I didn't submit the answer yet. I thought for sure I had it. That's not what I wanted to stop on. All right, so cache. .get. So I can look at my values here. Look at this, LRU cache is totally empty. Maybe I'm reading something wrong. How did I call this thing? So I'm going to undo and regret it, I'm sure. Same thing. Okay. All right. So if we step in, LRU at cache at key of 1 is missing. So, okay, well, good to know. We got a problem even before we get there. So let's try this again. All right, if we step into this, go through, nothing too exciting yet. I'm putting in a new node. And there we go. So now if I look at my LRU.cache, I should see a new list. It's got a key of 1. It's also the last. And we're setting cache at key of 1 equals blah. So if I go look at it, I see it right there. It's got a value of 1. It's got a node that points to the object. Okay. And that was it. So when we come into here, we go to put the 2 in. We look at our cache. I've got the 1 right there. It didn't do the bump. I got the former first item. Yep. I'm constructing a new node with a key of 2. Its next item is the 1. And its previous equals the list. Okay. So it must have got trimmed out. Former first item. Yes. We're setting your previous equal to our new node of 2. Yeah, that's fine. LRU. Our list.next equals our new node with key of 2, which also, just to double check, its next is set to a key of 1. Also good. So if my object.keys length is 2, and I'm checking to see if it's greater than or equal to. How did any of my other tests work? The capacity, it should only check if it's greater than. Okay. Well, that's a good error to have, I suppose. So now null equals undefined. I guess that's probably fine. If we run this whole thing, oh my gosh, we still got the wrong answer. What on earth? Undefined, undefined, fine, undefined, fine. It got a value here. I expect it to be -1. Wait, did I scroll up too much? What happened here? So check, check. Check. That was the one that was broken last time. Check. But I didn't get the 2. I got -1. But then next get, I asked for 1 and it still had it, which is wrong. Alright, well, here we go again. So we'll skip past that, and we're going to come in here and go look at our cache. I should see LRU cache.cache. It's got a 1 and a 3. It should have had a 1 and a 2. Isn't that right? Oh, sorry, not a 1 and a 2, a 3 and a 2. Let's push 1, 2, 3. So yeah. So when I pushed this item, the mistake happened. Let's go here. Man, I thought this was going to be an easy one. Here we are, hour and a half later. Man, time flies. Alright, what do we got? Cache is a 1 and a 2, so it looks good coming in. If we look at our list, we've got a list. The last item is the 2, which is incorrect. It should have had 2 as the next item and 1 as the last. So somehow I got that reversed. And I'm surprised because I haven't seen that before. So that means the error actually happened when we put the 2 in. So yeah, every time I change something, I'm breaking something. Yeah, this is happening in constant time. That's the whole point of me doing the linked list there, was to basically be able to, the doubly linked list where I keep track of the end. So basically I'm doing some constant steps in order to make it so I never have to iterate through the linked list. But it's been annoying. Yeah, for sure been annoying. Step into, yeah, and just the number of lines is super bad. And I should have known going in that I should have broken out my linked list to be just a separate class, and I could have just done some easy tests around it to test it individually. But instead it's like it totally embedded in my solution, and I didn't test in small chunks. So, you know, it's the same problems I have all the time. But the last couple days have been good, so I got cocky, I guess. So pushing in a 2 with a 2. We don't already have it. Our former first value is 1. Okay. Our new node is a 2. Our former first is not equal to null, so we should set our former first previous. Ooh, arrays and rotations. That's cool. They do what I'm doing, but a different way. Just some arrays and rotations. Yeah, you know, that makes sense. Dang. Yeah, that makes sense. If I would just keep track of where a pointer is in my array, then it's effectively a circular linked list, which would have been slicker than me actually doing all this previous next stuff. So I'm sure it cuts down the number of lines, and the operations are going to be faster than mine. Dang it. And you know, if I had separated my linked list from my implementation, then I could have easily swapped out at this point, but now it's so embedded in my code, I don't really want to change it. So I'd be starting the debugging process all over again. Former first is 1. Okay, its previous value is the head. So I'm saying, hey, the head is now equal to, or I'm saying item 1's, key 1's previous is now 2. So 1 goes after 2. Oh man, you know what? This is actually maybe not wrong. I think I might have typed the test wrong. So I pushed 1, I pushed 2, and then when I got 2, it bumped it. So I actually need to just run the solution and see how it goes. So I think that I think my test was bad. Almost. There's one that's off. Yeah, heck, no kidding, man. No kidding. Yeah, actually, I do talk about some streaming. Yeah, I think I mentioned you. I didn't do a very good job of mentioning everybody I've talked to in the stream, but I just kind of threw a couple names out there and said thanks for the help. And I believe you're one of them. If not, you should have been for sure. We just recorded that last night, actually. That's why I was so late getting on and why I've been so tired and messed up today. I always have some excuse, don't I? So which one was this? This was getting the 1. I said 1. They said -1. So I'm going to take their expected answers and actually make sure it lines up with what I got here. And just because this is annoying me, I'm going to write these as undefined. So undefined, undefined. The first one didn't count. Okay. Undefined 1, undefined. And here, this is the one that should have been a -1. Okay, undefined. Then -1, 3, 4. Okay, I literally did it wrong. Man. Yeah, you know, I said the thing that I need to remember. Literally in the episode, I said there's 3 things I always need to remember. I always mess up. Read the problem, manually solve it, and then test in small chunks. And this is the one that I missed this time. Those are the 3 things I try to I always try to remember. The acronym I use is RMS because it runs with Richard Stallman. Is the initials of a kind of notorious programmer. So that's, yeah, read, manual, small. And I failed at that today. Now I'm paying the price. All right, so just to run these guys again. This one is the one that is incorrect. Why is it incorrect? Because I've only got a capacity of 2, and we put a 4 and we got the 2, so 2 and 4 should be my only items in the list. Oh, but this was -1, so it's even more confusing. 3 and 4. So I'm guessing this extra bump messed things up, so I'm going to check here too. All right. So we got a 1 and a 3 and a pushing the 2. But we should actually, we don't have the 2, so it's -1. And we return, so no bump, so that's good. That's what should have happened. Now I push the 4. I'm going to go ahead and go in. Just look at what we got. So we've got a 1 and a 3. And we come out of this. I should have, based on the list, I should have. Next is null. What the heck? Next should never be null. I've got next of null and last not equal to null. Man. So where am I in the call stack? Ugh. So this was fine. So it's whenever I put this 3 on here, I messed up the next, I think. So let's try this. So let's make sure our list looks right when we started. Yep, we've got a next and a last. 1 and 2, that's good. Okay. We get the former first item. And we set the former first item, which is 1. We get your previous, which is the head of the list. And we say you're headed. Okay, this is where I messed things up because this should never have happened. I grab the 1 and I say the 1's previous equals new node. So what was I trying to accomplish with this line? Because this is not right at all. We're adding the item to the hash table with a pointer. Okay, so this is the put. The item didn't already exist, so we're adding a new item. I'm gonna have to shrink this font down just a little bit because I keep mousing over the wrong thing. Hope that's still readable. Alright, so we came in here. We figured out the former first item. The item that was previously in the list. And we said the one that's previous, get the former first item. What on earth am I trying to accomplish here? What did I mean to put here? So I could stop it. This is in our put. We want our thing to go in the first spot. So we got the former first item, and we say its previous. Man, I think this is doing the right thing. I'm just confused. That was okay, actually. Oops. That was a rookie mistake that I made there. I was just misreading. Now I gotta go back in. And sorry, today has been such a mess. Like I thought it was gonna be easy. I swear I've solved this one before too. This just feels familiar. Let's see here. You know, we get the former first item. Okay, and here's what I said. It's former first. It's previous. We're setting the pointer to the previous, not the previous item, is equal to our new node. Okay. So then our new nodes dot next should be set to our former previous. Did I do that somewhere? Yes, I did. It's set in this line right here. Next is former first. Okay. So that's good. Wrong answer, but it's good. All right. So now we're setting the first item in the list is now going to become a 3. We still have the last item, which is a 2, which is good. Okay, now we set our LRU cache at 3 equal to the 3. Its node is a 3, all good. Okay. If object.keys in my cache's length is greater than 2, so 3 is greater than 2, last time I checked. Last node equals LRU cache dot list dot last, which is the 2. That's okay. See, its next is null. That's good. Its previous is incorrect though. What happened there? Its previous is incorrect. So that is the problem. So this happened on bump. The bad thing happened on bump. Just to kind of write it out, we set the list last item equal to its previous dot next, which is the first item in the list, which is not correct. Okay, yeah, so that's where it got all messed up. So as usual, the place I thought the problem was actually happened higher up. So let's try this again. cache.get. We didn't have the item. Or did we? We do have the item. Okay. So if we look at our LRU cache, we should see that we've got a list. The next item is 2 because we just added it, and the last item is 1. Its next is null. Our next item, its previous is correct. Its next is correct. So everything is good there at this point until we go into bump. We know we have the item. I could even remove that check. But get the node. Okay, and this is the last item in the list. That's why it's next is null, the previous is good. So we skip this condition. Wait, what? Oh yeah, it is the last item in the list. And the existing node, its previous is not equal to, yeah, so it's not the first item in the list. Yeah, that's right. Okay, so in that case, the LRU list last item should equal my parent, which should be the 2. So that's good. So last is correct. Then we say, hey, your previous, that's where things are not right. So I say your list last is equal to your previous. No, that's okay. And then existing node dot previous. I'm sorry, this has got to be such a nightmare to follow. It's so hard to talk about it. Existing node dot previous is a 2. We're setting it equal to the one that's after me, which is null. Okay, so that's actually good too. My existing node dot next should be equal now to 2. Yeah. And my previous should now equal the head of the list. Yeah. And finally, my LRU, the head of the list should now point to my existing node. Okay, so it all sounds good, but I'm doing something wrong. So we come down here. So what I'm going to do is set my lists, which is just that kind of dumb header, so it has no key. Your next value is going to equal 1, which then points to 2. Its previous value is incorrect though, and it's not going to get corrected. So when do I correct its value? I did it just right here. Existing node dot previous equals. Oh yeah, I just read it wrong, man. I'm making dumb mistakes here. I apologize. So this looks good to me. So if I look at LRU Cache now, I should see 2 in the front. My what? Yeah. Didn't we just trace through and say this was good? And now somehow here I am. What did I do wrong? I've been making really bad, like, just dumb mistakes. I'll blame it on Friday. That's why I need my automation, my tests checking me, especially on Fridays. So what the heck? How did I end up with 2 as my last here? And what was my existing node? So I bumped my 1 when I got the 1. So this is all good. This is exactly what things should look like. I just keep getting confused. LRU Cache. I don't like looking at it like that. Yeah, so I mean, everything looks good here. The list looks good. It should be 1. And then 1 should point to 2. Okay, its next is null. Its last is equal to 2. I mean, this is all good. Okay, so we step out. And then we finally return our value here, which is 1. And that was the right answer. But then I accidentally hit the button to continue. So now I need to check when we put the 3 in. God, it's so tedious. It's like work. I should be getting paid for this. And yeah, I hate this. This kind of debugging is not even algorithm. It's not like challenging. It's just annoying. I guess the challenge is finding the bug as fast as possible. No bueno. All right, here we go. 3 doesn't exist. So we find the former first item, which is 1. Okay. We create a new node that points to 3. Okay. We have a former first. So we'll skip down here. Say your previous, which formerly pointed to the head of the list. Former first now goes after our new node. Okay, we already set new nodes next to the value of 1. Okay, so the 2 should be getting knocked off here. Okay. So if I look at our list now, it should be in good shape. So we have 1 too many values. Our next item is 3. 3 points to 1. 1 points to 2. And then next, going backwards, previous points to... That's wrong. This key is pointing back to the head, which is not correct. But how did I miss when that happened? Like, that didn't just happen now, did it? I was only messing with the 1. So that makes me think the error did happen up here and I just didn't see it. Man, down in the weeds. Step into, there we go. I'm just gonna quickly look at the list here at the end and double check that this is when things are wrong. So here our next item is the 1, good. Its previous is the head, good. Its next equals 2, its next is null. Its previous is incorrect, it should have been a 1. Okay. So this is the problem. My bump function is in fact correct, even though we just traced through it. We're so close now. How many times do I say that before it actually happens? Okay. We get our existing node. I guess I could verify the list here. I'm assuming it's been correct, but now I don't trust anything. Our next item should be 2. Yep. Its next item should equal 1. Yep. 1's next item is null. Next previous is 2, which is good. And 2's previous is equal to the head, which is good. So everything's good here. So I get the existing node. And if it's the last item in our list, and it is, this is like the main line that's different between other use cases. Ooh, I don't like this song. Hold on. Phew. I couldn't handle that one, sorry. Your list dot last is going to equal your parent dot previous, which is 2. Okay, that's fine. Okay. So I'm setting the new last of the list equal to the previous value, and I don't need to adjust its 2, it's still after the 1. Okay. Your next is 2, your next is 1. Your next is null, your previous is 2. Okay, so that all looks good. Does it look good now? It's hard to tell because I still have more changes to make. So I'm not even sure what I want at this point. My next value is still 2 because I haven't bumped the 1 yet. Okay. So we're slicing the item that we just found, which will be 1. So we take 2's next, which is 1, and we cut it out. So now your previous next equals whatever I had next, which is null. So that's good. The problem was I wasn't setting its previous correctly. Okay, I think I know what needs to happen. So we hop down to here. Now if I look at my list, our next value is 2. Okay, but its previous value is incorrect. So we need to, when we insert this into the linked list, we need to set this guy, its next dot previous equals us. Okay. But I only need to do that if it's not equal to null. Alright, let's see how this goes. Let me just run it down here. Okay, undefined, 1, -1, come on, really? Alright, I'm losing my mind. Existing nodes, next values, previous value equals the existing node. I mean, isn't that right? It's previous equals. Okay. List next equals. All right. This is gonna be the last debug. I can feel it. I forgot to set a breakpoint. I was so sure that I had it right. It's this one. I call get one. It should not exist, but somehow I had it. I really did forget which line I had this. I think I was actually looking up here. Okay, this is the last debug. So this is when the problem happened. So I'm going to zoom all the way down to... No, it was the get. It was the line above. Oh my gosh. It happens when we bump. Now I'm going to jump down here and see the order of the list here. The next item equals 2. I must have said the wrong breakpoint. There's only one item in the list at this point. No, that's not true. So this is wrong. There we go. There's the problem. Oh, but I hadn't corrected it yet. Let me just do this. And this one is just beating me up, man. All right. So come in here, we bump. This is the first time we ever bump. And it's a bad job of it. So here, our next item should be 1. Its next item should be 2. Its previous item should be 1. So that actually looks good to me. Our last item in the list equals 2, which is also correct. And just make sure 2's parent is 1. 1's child, or next one is 2. It's previous. I mean, that all looks good to me, actually. And yet somehow we're getting the wrong answer. Not there though. Things are still good there. I'm just gonna kind of double check the list. So our next is still 1. Our last is still 2. 1. Next is 2. Okay. Okay. Now we come in here, we get the 2. We should get a -1. I believe that's happening. Okay, now we come in and we put the 4 in. Crap, I wanted to see what happened on the bump. Oh, we don't bump. Because this is a new one. Oh, hold on, my wife's calling me. Alright, I'm on a deadline now. Oh my gosh. Where are we at? Yeah, to a 2-minute break, that would definitely help. Because, yeah, I think I'm just kind of... I've just lost the thread. I'm just not doing a good job. I'm debugging by coincidence, just kind of trying to trace through and see, rather than thinking deeply through the problem. Yeah, and for the music, I'm just hitting next, but this is not my thing. I'm more of a rock and roll guy. I can do like lo-fi beats, but I don't like the real funky stuff. All right. Okay, what am I going to do? I'm taking in 4, putting a 4. It didn't have it. So we're not even calling bump. So we get our former first value, which is a 3. And let's see. After 3 is a 1. But look, our last is still pointing to the 2. So it's wrong before it even gets in here. So now I guess the get 2 was the problem. I swear every time I change something, I'm breaking something. Alright, let's inspect our state here. Our list We've got a 3. The 3 points to 1. We got 2 as the last. That's incorrect. So it was wrong before we even got in there. So let's see what happens when we put this 3 in. Okay, we're putting the 3 in. It doesn't exist in the cache. Let's take a look at our linked list. Yeah, this is ridiculous. I'm spending so long debugging a linked list. And do you remember when I was like, oh, I don't want to pull this linked list out now because I don't want to waste all that time. And now here we are, debugging it in place, which is really annoying. So I've got a 1 and a 2. The 1 points to the 2. That's next. That's good. So everything looks good here. Our last item is the 2. So where did things go wrong? All right. I'm going to skip down to here. How did our list look at this point? We should have too many items in the list. We've got our next item, 3. That points to a 1. I'm okay with that. That points to a 2. The 2 points to null. Going backwards, the 2 goes to the 1. Yep. Its previous goes to the 3. Yep. And was the last correct? It points to 2. Is that what we expected? 3, 1. 3, 1, 2. So everything looks good there. So what happens in our removal? We get the last node, which should be a 2. Okay. Okay, I see. And then we set the last node dot previous dot next, but I never change the last. No, wait, yeah, I do right here. I said the last nodes dot previous. That's funny. I go dot previous dot next. It should just done dot previous. Going previous dot next is just setting it to myself. This is a dumb typo. Oh, now it's hard to read. Let me get rid of that. -1, all right values. All right, I think this is it. I can't imagine there being any more bugs. This is maybe just a lack of imagination on my part. I don't know, when do you think it's gonna work? 75 lines, that's ridiculous. Okay, that's all the right answer. First time, we've got to do it. Ah! Really? Line 65. Alright, let me translate this thing. Man, this has been so buggy. Lesson learned. RMS. Alright, so we had a cache of 1. And then we put a 2 with a value of 1. And then we got a 2. Did I read this right? We'll do a custom test case here and make sure. Yep, there's the error. Okay. Line 65. So when I put the 2, I should have got it undefined, and when I got the 2, I should have gotten a value of 1. Okay. That's all that stuff. Oops, okay. That was my prettier extension messing my stuff up. Alright. Line 65 error. Alright, the problem has been reproduced. Go look at line 65. Okay, I didn't check to see that this actually existed. It wasn't the last item. Oh my gosh. So many lines. So Abdul, when you do C++, do you do brackets for every if, or do you not? That's something I got in the habit of a couple years ago, and it's helped me. It hasn't prevented a ton of errors, but sometimes they can be tricky. Okay, so got the right value there. All right, let's make sure this still looks good. What? Didn't I just fix this? Did I not copy paste appropriately? Delete that part. Null null one, okay. Heck yeah, man. Where'd you pick up that trick from? You talking about when you say on their own line, you mean like this? I call that, I think of that as like C# style. I have no problem either way. It doesn't really bother me. Just, I installed that extension and it kind of has influenced. What? Null, 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 4, 3, 2, -1, null, -1, 2, 3. Man. Rewriting this sounds better every second. I don't really want to type all that stuff out, man. Alright, maybe it's time to rethink this thing. I mean, I feel like we're so close. I don't want to rethink it now, but man, this is painful. Yeah, I agree. I actually don't like it. It always bothered me with Python and the white space. That's a big reason why I never did it for like coding challenges or anything. I do think it's a better choice than JavaScript. I don't love Python. I had a dream last night I was a Python programmer. I had an old job that switched their code base over to Python. It was after I worked with them, but I had a dream I was working for them again. I was like, oh, I guess I'm doing Python now. Okay. I need to get a life, maybe. Nah. Alright, I guess I'm going to, I really don't want to program that. I mean, I'm just being lazy. Alright, I guess I would have been done now if I wasn't procrastinating. So we got a capacity of 3. Yeah, I am totally just going to program this. I'll remove the first item. Let's see, const test equals test.slice. So I want to remove the first item. Dot length -2. Const without first, sure. Ah, screw it. Then I'll just say, yeah, we can actually just do these either. Sorry, I'm talking to myself here. I less than test.length. Plus. We're starting at 1 though, skip that first item. And basically the deal is if test at I dot length equals 2. Alright. Oh, looking. Okay, so yeah, you do have the same one. Okay. Oh, I see. Okay. I see. Yeah, I like that. If it's a one-liner, I have zero problems with that. Okay, and I see here. Oh, hey, very nice, man. I wasn't sure what your Twitch stream was. I tried doing this. Twitch.tv/. But yeah, I didn't have any luck. So yeah, if you paste your link or leave a comment or whatever, I'd be happy to link to it and subscribe or follow, whatever. Yeah, I like that. If you ever see Ruby, they've got a thing where like you can say return -1 if. I actually like that. I thought that read really nicely. So I don't really miss Ruby too much, but that was nice. All right, so over here, if the length equals 2, then it's going to be cache.get. No, cache.put. Test at 0, test at 1. Else it's going to be a get. All right. And the get is just going to say, why did I do test at 0? It's not, it's test that I at 0. Okay. Get test at I. Here I'll gather up the results. Whoa. Results equals dude. Yeah, I gotcha. Yeah, I don't know. There's something about like those air conditions where you just kind of fail fast or get out of there fast. Like I always like having those on one line like that. To me, like those are kind of like edge cases that don't really make me think. Like I just want to get them out of my face, you know. All right. So there's the answer. I do like 2-string. It might look a little nicer. Or not 2-string. Split. Isn't it? Join. Oh man, I'm losing it. Okay. So the answer we wanted to see was this. So I'll actually do this and then push null. All this so I don't have to type that by hand. It definitely would have been faster to type it by hand. All right. Console.log, and this is what I wanted to see. So let's see how they compare. All right, finally. Wow, so was I really that far off? No. How did we get a null there? Oh, I didn't do the first one. Ugh. So we'll do this. Alright, I'm definitely gold plating at this point. Alright. So it was all good until we got to here. So what can I do about this? If I can like, I wonder if I could do like console.log, cache.list. All this has been this stupid linked list, which is like so minor. All right, can I do that? just do that. Let's see what this looks like. It's gonna be really hard to read. Yep. Yeah, this doesn't really help us. I only want to see it when there's a problem. So yeah, that's too annoying to read. I don't want to write a function to print out my linked list. So what are we doing here? We're doing push, 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 get, 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 get. Yep. What's up, Yala? It's on YouTube on the name Yala Coding. Okay. Well, let me do it in my other browser. Coded blog. No, YouTube. Let's see. Y'all coding. All right, man. Subscribe. All right, awesome. And I want to hit the notification bell. Boom. There we go. All right, man. I'll be keeping an eye out. Awesome. I'm looking forward to watching it in Arabic. I don't know anything about it. Oh, yeah. I figured it out. It's all good. Man, I mean, we're creeping on 2 hours, right? Like, why didn't I just start over? All right. So what did we do here? We pushed to 1, we pushed to 2, we pushed to 3, we pushed to 4. The 1 should have dropped off. So at this point, we should have had 4, 3, 2. And we check 4, 3, 2, 1. We get 4, 3, 2, negative 1. So we're good up to that point. We push a 5. I ask for 1. It's negative 1. That's good. Now I check for 2. Oh man, all good. I appreciate it. So why is 2 even in here? Oh, because we got it recently. Okay. Oh man, well thank you very much. I'm glad to hear. I'm glad to hear it. I think it's a lot of fun just to code and hang out talking. The downside is people get to see all my mistakes. Hopefully it makes you feel better about making your own mistakes, 'cause we all do it. So now when I got to 3, they were able to retrieve the 3 and I was not. But looking at this, they fetched the 4, they fetched the 3, they fetched the 2, they fetched the 1, which didn't exist. So that meant that at this time, the array was just 4, 3, 2. Except the order was 2, 3, 4. Now we pushed the 5. Okay. We check for 1. So that should have been negative 1. Okay. Now we check for 2. 2 should have been in there. I didn't have it though. So somewhere in here there's a mistake. I'm guessing it's the bump. Man, you know what I'm gonna do? Watch this. This is gonna be ugly. Watch this. Let's see. This is our expected. This is going way out of the way. Ugh. Whoa. Alright, and we got our results, which we're pre-filling with the null. Nope, now we're gonna change it. We're gonna pre-fill with this at Hey, where did my input go? I did something wrong. Where am I getting my input from? Where's my test? Oh, I deleted it. Okay. All right. Jeez. All right. So now I'm going to take our expected. So this is about to get super nasty. Also, I can save a little bit of typing. All right, so now I've got my expected. Now, this is going to be LRU Cache. You forgot what I'm doing yet? Yep. This is how far I've fallen. All right, then here, I don't want to push the results. I'm actually going to generate the code that says results.push. This is the dirtiest thing I've done all week. Cache.push. That's saying something. Okay. .push. Cache.get. Yeah, this is embarrassing at this point. There we go. But this time we can just do a new line. I do this right? There we go. All right, and I will, above each line, I'll console.log, no, I'll results.push, a line that tells me what the expected should have been, which is here. Expected, oops. Expected at I. But I need that to be commented out. All right. All right, now I can comment all this garbage out. And here is the test code. All right, that was grody. All that to save that much typing. It's ridiculous. Oh my gosh, of course. I didn't start at 0. Oh my gosh. I'm so sorry that this is painful. It's ridiculous. All right. Okay, now. I didn't console log any of this stuff. Oh my gosh. Man, I'm just gonna regenerate. I don't really want to do that. I know the error was. The error was around here. Right here. Answer. All right. So here I did a 2 and it should have been a 2. So was it the 3 that was the problem? Yeah, they expected a 3. Oh my gosh, this is ridiculous. I'm just gonna do this. You ever do stuff like this? This is not my normal MO. Believe it or not. So I want console.log, all this stuff. But even then, let's go ahead and put this expected value in here. Put all this stuff back in. We're gonna console log. Oh, I wiped it out of my clipboard. Yeah, I was just trying to be lazy, but I out-lazied myself. I want to see expected at I. That's going to be a value. Equals. Oh my gosh, this is even worse than I thought. I've just gone way off the rails. So I want to console.log the number 2, for example, equals. So like this. Something like that. What are the chances I got this right? Oh my gosh, I did it on the wrong one. Whatever. That's fine. Should have been cache.get. Console log expected equals plus cache.get. There we go. Alright, let's try that. Equals plus. So if I take this code, can I run it? I should do this in another file. I'll call it shame. Shame LRU. There we go. Alright. So if I run LRU shame. What? Where'd my stuff go? Oh, I need to note it. All right. So if I run LRU, oh, give me a break. Oh, I did the same thing again. I need to note it. I definitely feel like I'm getting worse by the minute. 1 equals -1. That's fine. -1 equals -1. 2 equals 2. 3 equals... Ah! That's wrong. Not that 3 though. This 3. So at this point, this is what I want to see LRU cache dot list. And I'll just set up breakpoint, sure. All right, what do we got in here? We got a 5. The 5 points to a 2. The 2. The 2's next is the 5 again. No, geez, I keep doing this wrong. Let me just start over. My list has an empty header. Its next value is a 2. The 2's next value is a 5. The 5's next value is null. That doesn't sound right. What is your last value of the 5? So I only have 2 items in the list at this point? I don't believe that. My LRU cache size should have been 3. So what happened? I pushed a 3. No. I create... Oh, this is wrong. I had a bug in my code. This thing. Surprise, surprise. There we go. Alright, well, fix that bug from now on. So now if I do this and rerun it, what do we get? Where's the first wrong answer is right there. Still the same spot. Okay. So we stop this, run it through. At this point, the 2 should be the head because we just got it out of there. We don't have a 1. A 5 should be in there. We still don't have a 1. But I don't understand why a 2 isn't. Oh no, we said a 2 was in there. I don't understand why the 3 isn't there. So we look here, we've got a 2. Yep. The 2 points to the 5. Yep. But its next is null. What happened to my 3 here? I lost my 3. Okay. When did I lose my 3rd value? And my lazy debugging is not doing any favors. I should remember the Vlado's eagle eye. All right. 5 points to 2. Next is null. This is already incorrect. What's crazy is the get got 3 values in a row. So I felt like at this point it probably had the right stuff going on. So let's check it out. After here, what I expect to see is this is after we put all the values in. I don't want to see that. I want to see it after here. We got a 2, 3, and a 4, and the order should have been 2, 3, and 4. Because that's the reverse order of when we got them. Oh, I forgot to break the point. All right. Remember like an hour ago when I said this would be the last debug? All right. 2. 2 points to 3. 3 points to nothing. It's already incorrect. It's the bump function. All right, let's go up the stack. Here, I expect to see 3, 4, and then a 2. And instead, I've got a 3 and a 4 and a 2. So we're good here. And then that's good. So this is the last good spot. And then we go and we get this 2 and things get messed up. Just gonna verify that before I go in. So here we should expect to see a 2, and then a 3 and a 4. Instead we have a 2 and a 3. So we totally dropped the last item. Okay. Alright, this is going to be very exciting. We're so close. It's unfortunately this is the bump function, which is the most annoying function in this whole thing. Does our key exist on our cache? And the answer is yes, it does. Let's look in that cache. Yep, there it is right there. Okay. So in that case, let's go get its node from the linked list. Okay, there it is. 2, it's the last item in the list. It does have a previous value, that's fine, it's the last item. If your existing node's next is null, yes, it is. And its previous value, oh, hey, this is a special condition. Its previous value is not equal to the head of the list. It's not, it's equal to 3. Then what we said needed to happen here is the last item of the list needs to change. And LRU.list.last we're setting to the previous value, which was the 3. So that's okay, but what I expect is happening is that we're probably bumping this again later. This is probably one of those things we fixed a bug later and it invalidated this check. So let's check. When else did we set this value? We don't. So actually this looks good. This is what should have happened. LRU list last should have gotten set to 3. I'm okay with that. And just to look at this thing again. We've got 3 pointing to 4. Okay, that's not right, which points to 2. I got the existing item for 2 here. Yep, this is 2, and I said get your previous, which was 3. But if we look at our list, 3 is the first item on the list. So this previous value was incorrect. My previous value should not have been 3. Existing node 2, its previous value should have been something else. So if we look down here, its previous value should have been 4. So last good spot was actually not the last good spot. My goodness. What was wrong with this case? 2's previous was incorrect. I'm gonna just verify that one more time. If we look at my last value 2, its previous was 3. And it shouldn't, because if we look going down this way, 3, 4, 2. So man, this is ridiculous. Again, it's the stupid linked list. Okay. Man, I've never had such problems with the linked list. I should have just started over so many times. I'm going to stop saying that. I should have stopped over. It's got to be annoying when you repeat the same thing over and over. I'm annoying myself. Alright, let's see what things look like up here. So we had a head. We went 4 points to 3 points to 2 points to nothing. Okay, what about going backwards? 2's previous was 3, 3's previous was 4, whose previous was the head. So it looks good there. So I think that all worked all right. It was just this first get, or this get. One of these guys messed this up. We'll wean it down. So this is now the last good known spot. And this is the one we're investigating. So we go from 4 to 3 to 2, and it goes back to 3, and it goes back to 4. Okay, and let's check the last value. Pointed to 2. Yep. So let me put that in there. 4, 3, 2. So now we got the 4 again, but we didn't have to bump because it was already correct. So this looks correct to me. And it didn't change the order, which is interesting. It was already there. So is this it? Let's see. Okay. Let's go in. So now our list was at 432 and we're getting the 3, which should bump it. Now it should go 3, 4, 2. So we got the 3. We do have this value in there, so we should bump it. And at the end we'll set 3 equal to, we will return the value of 3, which is okay. See what that is. 3. So the cache does exist. We find the existing node. That's good. 3, its next is 2. Its previous is 4. Yep. And just double check our LRU cache. Make sure it's list. Its last item is the 2. Its next is the 4. We just verified the order, so we're good. Now we're going to slice out our existing node by going to its previous, which was the 4, and setting the 4 now equal to the 2. Good. Okay, so 4, but don't I need to set the existing nodes next to our previous? Okay, I do that next. All right. Oh, but I should have done this in a different order. I'm resetting the value. Existing nodes next equals this. No. This needs to happen first. If my next isn't null, then I need to set my next's previous equal to me. And then I can change this. Alright, I think that was it. Now let's see what other stuff I broke this time. 2. Man, still wrong. Isn't that incredible? How can I fix a bug and still have it be wrong? Next previous goals, and then we take your next item and set you equal to the front. Man, I am getting so tripped up here. Why didn't this change anything? There's the problem right there. Same problem. Okay, well, let's go look. This is our last good state. I'm doing 4 down to 2, but not the other way around. We're doing 2 to 4, not the other way around. Maybe I don't understand. I don't think I understand what you're saying. Just to double check it, 4 goes to 3, 3 goes to 2, and back up. 2 goes to 3, 3 goes to 4, and the last item on the list is 2. So everything is good here. Then we do this. All right. We go into bump. We find the existing node. It's not the last item in the list. It's in the middle of the list. Okay. So we need to slice it out of the list. And the way you do that is you take your previous value 4 and you said it's next. So it points to 2. Yep. On line 54, I'm skipping the 3. Yeah, I'm skipping the 3 here. And then I take the existing node next and say if you already had a next, then take that next value, the 2, and set its previous equal to existing node. No, it shouldn't be existing. It should be equal to existing node dot previous, which is the 4. Yep. So is that what you're saying? All right, so what happens then? So now if we look at our existing node, it's a 3, its next equals a 2, the 2's next equals null. Okay, but we're gonna fix that now by setting it equal to the 4, okay? And then we set its previous value, which was the 4, now to the head of the list, okay? So now if we look at existing node, the 3 points to the 4, the 4 points to the 2, going back up, its previous is 3, and its previous is, wait, 3, 4, 2, this should be the 4. Hold on, I'm getting confused, but I think this is closer to right. The 3 now points to the 4. The 4 now points to the 2. The 2's previous is wrong. The 2's previous should be the 4. Didn't I set that up here? Oh, I changed it, but I didn't rerun it. All right. Duh. Oh, I skipped it. And I skipped it again. Oh my gosh. All right. So we'll zoom back to where we were. And I hope this is it. I let my... Okay, we're resetting that, so fine. So the 3's next is now the 2. The 2's next is null. Where'd the 4 go? 3 goes to 2. Oh my gosh, man. Okay, so maybe fix one problem, broke another. So we're getting, we don't have it, we go to bump. We do have the value, so we get the node. The 3's next is not equal to null. So we're gonna move on. Okay. Now we're gonna slice out our next, we're gonna slice out the 3 by saying, hey, you go get your previous, which is the head of the list. Is that right? Yeah, very likely. Very likely. Yeah, I'm sure I'm missing null checks, man. That's the kind of errors I was hoping to fix. Existing node dot previous. Why is my previous the head? I didn't expect that. I'm gonna verify my state again, my last good state. Suddenly I don't trust it. I made a change, so I can't take it for granted that's correct. Now I expect to see a next of 4, which points to a 3, which points to a 2, which goes back up. 3. Three's previous is what? Start that over. The 4 points to the 3. The 3's next is 2. 2's previous was 3, and the 2's previous value is 3. The 3's previous value should have been 4. So we can see that problem right here too. Previous is not correct. So this is no longer bad. 3's previous should have been 4. Okay, so hopefully that's just a case of fixing one problem, broke another thing, or exposed another problem. Man. So this is the last good known. And I can't take for granted now that any of this stuff is correct anymore because I made changes. Alright. So at this point we pushed a 1, 2, 3, 4. We should have a 4, 3, 2 left. No, not at all. What did we do? Haste bin last time? New. Oh, let me go here. There we go. So I just keep getting tripped up, man. Save me. Save me, Abdul. Y'all coding. No, thank you. My list. So my next value is 4. My next value is 3. My next value is 2. Going back up, my previous value is 3. My previous value is 2. So it's good here. But then I go and break it. So we're going to end up bumping the 4. The item does exist. It does exist in the cache. Yep. My next is not null. Okay. Now I want to be slicing the 4 out. So I take your previous, which is the head of the list, and I say, hey, now you're equal to my next, which was the 3. That's good. If my existing node's next, which was the 3, is not equal to null, it's not, then we're going to take the existing node's next, which is 3. What? Okay, previous value. And we're going to set it instead to my previous value, which was the head, which looks good. So we'll step through that. All right, so now if I look at the list, my item should be cut out. So now we've got the 3. The 3 points to a 2. Does it correct the other direction? My previous 3 goes to a 3, and its previous goes up to the head. And the last item in the list is the 2. So we are good at that point. Everything, I'm happy with that. Now we need to put it in the front by saying existing node dot next equals the head's next. Okay, so my 4 gets reassociated to the 3. Okay, and I say my previous is now equal to the head. Okay. Now then I say I didn't fix the 3, did I? So I come here and look at the 3, its previous is still pointing to the head. So I did not fix the 3. So I bump the item in by inserting it to the next. Okay, and then existing nodes previous, which is the head, equals that. LRU Cache dot list dot next equals existing node. So I never did this part. I didn't take the next and set its previous equal to existing node. Man, this is so ugly. So potentially I do have that issue with you know, I'm not doing any null checking, being real sloppy about that. So I expect that to come back. But let's see. Previews. Okay, so we got right answers this time. So I'm just going to take it and dump it over here and just see how it goes. Back to problem. Alright. See how we do on the sample test case. Right answers. Okay. We'll do a custom test case. I don't want to. Let's just submit it. I'm sure that there's a problem with, yeah, not checking nulls. So that's where it got us. I've been really sloppy not thinking about that at all. It's crazy to me to think that I need more lines. Existing node dot next. Dot previous equals existing node. Isn't that exactly what I checked here? So why didn't I set this before? Existing node. Oh, I see. Okay. Man, this is really confusing me. Okay. Yes, Yala, totally. That is the problem. Where is this problem? Oh, my wife's home, so I'm in trouble. I'm not in trouble. I just gotta go pretty soon here. Oop, it's not equal to null. Yeah. Okay, so we still got the right answers here. That's good. Let's see here. Alright, this is it. Run the test code. We got the right answers. We submit. Oh my god. Oh my god, got it. Oh my gosh, look at that. Oh my gosh. So lessons learned. Lessons learned today. I tried to do something really wacky and tricky when I could have done something easier to get the problem done. I didn't test in small chunks. And then even long after I knew I had just a messy solution that should have been done a different way, I tried to stick with that strategy, and this is my reward. So yeah, thank you. Just not great. Hey, what's up, Nicola? Didn't know you're here. I hope you're having a good day. Yeah, so I definitely learned some lessons. And the sad thing is that I totally had the solution within minutes, and then I just spent forever debugging this monster mess, which was just totally unnecessary. Oh gosh, I don't even know if I want to look. What happens if we look at the best solutions? I was being lazy. I was like, oh, I don't want to rethink the problem because I don't want to type all this again. Oh, at least this is kind of long. Let's see here. I wish they put comments in here. Linked list, constructor. Okay, so they did a linked list. New linked list. They kept track of the tail and the head. They add the node. It's still kind of tricky to read, but it is much easier. Oh, they don't do a hash table here either. Okay, there it is. There's the hash map. So this was the solution I was looking for. Move to top. They did separate out this function, which is what I should have done. This is the thing that I wish I had separated my... This is the one thing I wish I had done most differently. Is I wish I would have separated my my linked list from the rest of my logic. Because then I could have just had it look like this, which is still pretty tough to read. So I don't know. I don't hate that. I mean, I like that my solution looks similar to this. I don't know what I did so wrong in order to end up being so poor here. But I'm glad to see at least it wasn't too far off. Here, another one, another linked list. And tail. So I'm going to go out on a limb here and say that it was basically my implementation was poor here. I think my solution was good. I just did a very bad job of programming it. I tried to cut corners. I didn't test small enough. And yeah, that was it. So hey, Nicola, if you like watching streaming, I just found out about this new awesome streamer who's in this chat with you. And so let me get that. I just subscribed to him, but then I shut the window. It's Yala Coding. Oh my gosh. /Yala. Oh man. Alright, I'm a mess. Oh my gosh. What is wrong with me today? I mean, I literally had this a few minutes ago. I could have swore, didn't I? I followed. Alright, Abdul, I don't know what I did with your link. I just had it. I know I followed. So I don't know what I did wrong here. Yeah, I don't know. Here we go. Man, am I? Oh, it was on YouTube. Duh. Okay, man. I'm so sorry. God. So like that? Nope. Oh my God, Abdul, how did I? Yeah, YouTube. How did I lose your channel? Like, I just subscribed to this like minutes ago. There we go. Oh my gosh. Okay. All right, there we go. And I'm gonna go ahead and take a note here. Let's start a bookmark folder for streamers. And I'll get a blog post out there, or a YouTube or a GitHub page or something. And let's see here. I want to go to, yeah, this page is good. All right, cool. So I'll get that out there eventually, and I'll find a way to link that. So cool, man. I'm looking forward to watching that, and I'm really excited about watching it not in English, so that'll be cool. I think it's gonna be neat. So all right, cool. Well, I hope you all have a good night. I had such a tough time with this one, but I really do feel like I learned some stuff. Hey, Nicola, good luck, man. Good luck. I definitely recommend doing leak code. Some of the problems I've felt really good about, and some have really beat me up, but every time I do one, I feel like I learned something, so I definitely recommend it. And yeah, good luck, man. Also, if you haven't seen it, there's a service called interviewing.io. And check this out, man. You can, for free, go and, you have to do a coding challenge in order to do it. But you can do practice interviews for free. Well, they will literally, you'll schedule a time, and you'll go with a live human, and they will do an interview with you, and at the end, they'll let you know feedback, like on how you did, what they thought. It's just such a great way to practice. And I did this a bunch once, and I think it really helped me kind of not get too nervous in the interview, because I talk too much anyway, and when I get nervous, it just goes off the rails. So I thought it was super good and free. So, oh, also, I didn't know they had a YouTube channel. Oh, hey, I got something happened. I don't know what happened there. I got a notification, something. Maybe somebody subscribed. Hello. All right, let's see. YouTube interviewing. .io. Didn't spell it right, but yeah, that was it. Cool. Awesome, man. I didn't know about that. That's awesome. Man, that's cool. Okay. Man, 4 days ago. This is awesome, man. I'm looking really forward to seeing this. So this is cool. Man, perfect. Okay. All right. Well, I'm gonna get out of here. I haven't eaten dinner yet. It's late, so hope you all have a good day, night, whatever it is.